Outputs contain the details of the destination to which the bitcoins are sent. I repeat what I said at the start of the block structures. We are discussing the block structure through an example of Bitcoin. But all blockchain blocks are more or less similar in the structure. Let us now look at how a block is formed in blockchain. Remember that blocks are nothing but grouping multiple transactions into one. So first, let us look at how a transaction is done and represented in blockchain. Customer C buys a cup of coffee from a cafe. The cafe owner O accepts Bitcoin as a form of payment. C decides to transfer 0.15 BTC to O as payment for the coffee through his Bitcoin wallet. We will understand the fundamental concepts involved in this transaction process by explaining them in detail as we traverse through the various stages. Customer C is essentially a node in the blockchain, having a wallet which currently has aggregated 3 BTC. So, if C has 3 BTC in his wallet, it is an aggregation of all the unspent transaction outputs, also known as UTXO, which are nothing but the bitcoins he has received earlier. Just as rupees can be divided down to 2 decimal places as paisa, Bitcoin units can have 8 decimal places called satoshis. What is UTXO and what is a UTXO pool? The fundamental building block of a Bitcoin transaction is an unspent transaction output or a UTXO. UTXO is an indivisible unit of currency logged to a specific owner and is recognized by the entire network. The network tracks all the available UTXO, that is, unspent assets. Whenever a user receives a Bitcoin, that amount is recorded in the blockchain as a UTXO. When C checks his account balance, the wallet will show a balance of 3 BTC. The 3 BTC is an aggregation of all the UTXO belonging to the user, which are scattered across the blockchain but locked to C. The same can be represented as 3 BTC equal to 0.8 UTXO plus 1.3 UTXO plus 0.4 and 0.5 UTXO. Since C has 3 BTC and has to pay 0.15 BTC as payment, the transaction will consume the 0.4 UTXO and produce two outputs. One paying 0.15 BTC to owner O and another paying 0.25 BTC in change back to the wallet of C. This transaction can be represented as customer C 0.40 BTC going to owner 0.15 BTC plus customer 0.25 BTC. The UTXO consumed in a transaction are called the transaction inputs, and the UTXO created by a transaction are called the transaction outputs. Another way in which this transaction is ideally carried out is represented as 0.4 BTC, owner gets 0.15 BTC, plus customer gets 0.2 BTCs back and a fee of 0.05 BTC. Change or fee of 0.05 BTC will be the transaction fee. Now what is this transaction fee? For every transaction that is sent to the network, the source attaches a transaction fee along with the transaction. Transaction fees are incentive to include the transaction in the next block and also as a disincentive against spam transactions by imposing a small cost on every transaction. Miners who form the block collect the transaction fees. This block ultimately records those set of transactions in the blockchain. Now you may ask how a block is mined. A node will add validated transactions to the transaction pool where they continue to persist until they are included into a block. If this node is a miner node, it will start aggregating these transactions into a candidate block. The miner node adds other transactions from the transaction pool into the candidate block and readies the block for creation or mining. Remember, miners are inclined to include those transactions that are having a fee or incentive attached. If we consider the above example, that a transaction fee of 0.05 BTC was attached to this transaction will be given a higher preference. If no transaction fee were assigned, there would be less incentive for miners to include this transaction in the candidate block. The chances are that this feeless transaction will be delayed in processing. All the transactions which are not selected for the candidate block continue to remain in the transaction pool. Also, an unconfirmed transaction can be a part of more than one candidate block. Once a new block is mined through consensus mechanism, the mining node sends it to all its peers while adding it to his blockchain. Each node on the network validates the new block and then propagates it to its peers. As every node validates the block, it finally becomes a part of the blockchain. All the transactions that were a part of this new block are then removed from the transaction pool of each node. This process explains the journey of a transaction until it finally becomes a part of a block. Similarly, other blocks are formed which contain different set of transactions. Each new block that is formed is linked to the previously formed block linearly, thus creating a chain of blocks called the blockchain.